Okay, it's gonna keep playing the video. There we go. All right. This is another process. I like to think of it as there's a couple of different pillars of 3D printing. There's powder-based processes, there's UV curable resins, there's inkjet techniques, and then there's extrusion-based techniques. Those are the four main, at least that I see. This is a resin-based process. This is one of those UV curable resin technologies I was telling you about. In this case, they use a bath instead of an inkjet head, but it's essentially the same type of material. It's called a photopolymerizable resin. What that means is photo meaning light, polymerizable meaning the polymer goes through a phase change. So the liquid itself, when you expose it to typically 118 angstroms of light, which is blue light, just that are coming out of these lights from normal spectrum of light from the sun, it causes it to go through a phase change and solidify. Okay, so this was printed on a Formlabs machine, and what they don't tell you is that if you don't fully cure it when you're actually printing it, and then you leave it out in the sun for a long period of time, it'll continue to cure. And these parts become more and more brittle over time. So these resin-based processes, at least from what I've seen, they're not very good at withstanding heat, and they also become worse. Their mechanical properties vary over time as they can continue to get exposed to light. So you always have to keep that in mind as you're designing with a process like this. The plus side of a technique like this is you can get really, really high resolution. You can get very beautiful looking parts, but they'll only be beautiful for so long. Like with age, beauty fades, right? One of the other downsides of this technique, just like the powder-based techniques, is you're limited to one material at a time. That's a pretty big deal when you're thinking about support structures. If you want to print a complex geometry that, with gravitational effects, would cause the material to sag or deform, you need to put a support underneath it to make sure that it maintains its position. And with a single material process, you have no ability to have multi-material interfaces. And what I mean by that is, with the FDM technology that I'll get into in a few moments, you can print two different materials, and then afterwards put it into a bath of a specific chemical that'll dissolve one and not the other. But if it's made out of a single material, you have no opportunity to do that. You have to mechanically remove all the support material. This is to show you what you want to print. This is what you end up having to print because of the support material. Everything in purple is not necessary. It's not desired, but it's necessary to actually make the process work. And this is what it looks like afterwards. So the beauty of this process in terms of the surface finish that you get is diminished radically when you have to remove the supports, because the supports leave little interfaces on the part that don't look good. Whoops, wrong way. Okay.